let's take a look at some linear regression. So what linear regression means is we're going to have some points, some data points. Got some here. We'll talk about that in a sec. We're going to plot these points and create a scatter plot, and then we're going to put a line of best fit through those points. And that's what's called a linear regression, coming up with a linear equation given a set of points. So in this situation, we've got some elevation above sea level here and air temperature outside. So you can see at sea level here, the air temperature is 27, and as we start going up in elevation, the temperature starts to drop. And it looks like it's dropping more or less in a linear form. So what we're going to do is we're going to plot these points and see what that data looks like. And then a little later on, we're going to answer some questions about some temperatures at different elevations. This elevation here falls somewhere in here in our data, and this elevation here is outside of the data that we're given. So let's plot these points here. So I'm going to go to Desmos, desmos.com, and I'm going to create a table. Okay, so this creates some x values and some y values. So we have 0, 200, 400, 600, 800, 1,000, 1,200, 1,400. How far did we go? I know it was going up by 200s. We went up to 1,600. Okay, now I'm going to copy these temperatures in. 27, 26, 24, 22. 27, 26, 24, 22. 21, 20, 19, 80. 21, 20, 19, 18. 21, 20, 19, 18, and then 16. Okay, so here they are plotted on our graph. But you can't see anything because these points, these y values, 27, 26, are up beyond our graph. So what we're going to have to do is expand this axis here. And look at our x values. They go like 200, 400, 600, 800. So we're just seeing this first point right here, but my scale is like 2, 4, 6, 8, 10. So I could continue to pinch this. This is one way of doing this, and eventually we're going to see the points come up here. There we go. Or the other way you can do this is let's get this back. The other way you can do this is you can go up here to your graph settings, and you can adjust the x-axis and the y-axis. Just put the points right in here that you'd want them to go to. So from 0 to 1600 on x, 0 to 1600, and we've got 16 to 27 on the y-axis. I like to be able to see the x-axis and the y-axis, so I'm good with this. And let's look at the data. It's pretty linear. It looks like it's going down at a fairly straight way, so a fairly consistent slope going down there. So I think coming up with a linear model for this would be a nice fit. So remember, the equation of a line is y equals mx plus b. That's the linear model for a model for a line. So in our case, let's go back to our graph, and what we can do here is we can start another equation, and we're going to get Desmos to actually give us this model. So I've got y1, that's these values here. And then to come up with a regression model to tell Desmos to do that, we don't actually hit the equals sign. So right underneath probably your escape button, there's a little squiggly line like this. That's telling Desmos, let's do a regression, please. And then m, and then x1, because I have the x1 values in here, plus b. So what it's done now is it's put a line of best fit through these points, and it's told us what these parameters should be. So it's telling us what the slope of the line is, and it's telling us what the y-intercept of the line should be. So we now have our equation. So there's a double 0 and then a bunch of 6s. So we'll say the temperature outside, instead of Y, we'll use temperature, is negative, no, I can't remember that number, 0.00 and then the bunch of 6s. So we'll put a bunch of 6s in here, times X, which is actually our elevation. So let's do E for elevation, plus our y-intercept, which was 26.7778. Bunch of 7s and an 8. That's a 7, so we're not confused. Okay, so now we have an equation that should give us an approximation of the temperature at any elevation you want. So when it says what's the temperature at 700 meters, I've got actually 3 ways I could do this. I could look at my table and I could say, okay, 700 is like halfway between 600 and 800, so maybe 21.5. That would be using the table to approximate that. We could go back to our graph and see, okay, here's 700. So we could look up here and, yeah, what's that? 22.46. So 22. Yeah, so somewhere around 22 from the graph. And then we could also use our equation that we have right now. So I'm actually going to use the equation. And I'm going to put 700 in for my elevation. Let's clear this. So negative 0.00666666. Those are just a bunch of repeating things, times 700 plus 26.77778 gives us a temperature of 22.11. So that is our approximation using our linear model. Now, what you notice here when you look at the graph is that 700 right in here was within the data points that we were given. So going back to the table here, anytime you're asked to find a point that's within the data that we were given, this is called interpolation. So yeah, this is called interpolation, since the 700 meters that it's asking is within the data that we've been given here. So our model showed that that was 22.1 degrees using our linear regression. So now the question says, what's the temperature at 2,000 meters? Well, 2,000 meters is outside of our table there, and our points end at 1,600, but we can look on the graph and see that it looks like it's just going to be under 10, 12, 14, just under 14 degrees, maybe from our graph. So anytime you're looking at data that's outside of your data that you're given, so 2,000 meters is outside of this information that only went from 0 to 1,600, that's called extrapolation. So we call that extrapolation, not extrapolations. Extrapolation, since the 2,000 meters is outside of our data. So but we can still use our formula. So now what I'm going to do is I'm going to put, for the elevation, let's put 2,000 in here. So back to our data. Actually, what I'll do with my calculator is I will just go back in here and change the 700 to 2,000 and hit enter again. And so we got 13.4 degrees. 13.4 degrees Celsius using our model, our linear regression. So that's how you can use Desmos to do a linear regression on some data and come up with an equation that you can use to either use interpolation or extrapolation.